everybody. Welcome to, well, this is kind of Sonic Talk presentation, or I don't know. We'll figure out what it's called a bit later on. But I'm really pleased because if you watched our NAMM coverage, you will have seen that we had a video with GPU Audio, who are kind of doing some really clever things with accessing the GPU power of many computers, are sort of the untapped resource, and using it for processing audio. And it was actually our biggest video from NAMM, sort of unexpectedly. I mean, because normally we'd expect synthesizers and whatnot, but this was actually a really unexpected big hit because it feels like there's a lot of interest. So, I mean, obviously, being the person I am and being the editor, we've got to talk to these guys in more depth. I want to thank Chris very much, and we've got John Rowden here, and we've got Sasha, and we've got Basil, who is just a faceless screen because he's going to be showing us a couple of things, hopefully. How are you guys? You all right?
Yeah, I'm cool.
Yeah, doing great. Thanks, Nick.
Excellent. Well, I'm sure your live is spent looking into webcams, so I'll try and make this as painless and as flippant and as fun as possible. So really, what I wanted to do is, because I think looking at the comments of that video, lots of people kind of were gagging for it, which is very, very clear. Lots of people were kind of maybe not totally sure about what it was. So I think maybe the first thing that we could do is clarify exactly what it is that you do, because as I understand it, you're creating this kind of middleware translation layer that allows regular audio plugin type stuff to talk to the GPU and get all of that goodness. I don't know who wants to go first on that. Yeah,
I can offer a brief comment about that and then let Sasha go into more detail. But I think part of the confusion comes from the use of the word standard, you know? So what we're doing is we're building a processing standard, right? So a processing standard this is different than like a plugin standard, for instance, right? Like CLAP is a new plugin standard, right? But GPU Audio as a middleware processing standard can be implemented into CLAP, you know, potentially into AAX, into audio units, VSTs, and also just standalone software that doesn't have to make use of, you know, these plugin layers or, you know, these plugin SDKs entirely, right? So GPU Audio really is like a core technology innovation that's unlocking GPUs for two things: for DSP parallelization, so for like, you know, the parallelization of algorithms for DSP, and then also executing those in real time across the GPU, across the cores. So that's the easiest way to sum it up, or at least how I do it. Sasha, what do you?
Well, I wouldn't add anything to this, but I can add a very few, you know, technical details. So you may compare this to DirectX or any other shader language, with the difference is that shader languages and these kind of frameworks, they're super common and people know how to program it. GPU Audio is not that way common yet, but the difference is that we offer some new features in the platform that allows the other third-party developers, future SDK users to bring their own plugins, software, tools, whatever, through all of the bridges, CLAP, VST3 audio unit, or their own bridge if they are willing to connect to their own software, and basically to unlock their full computing power potential of GPUs and to do their own thing. And it doesn't matter what it is. I mean, it doesn't matter whether it is classic DSP algorithms or machine learning stuff, because we can run any machine learning algorithms using CUDA backend or using even Python backend. It just depends on whatever you need. And with that thing for developers, we can bring in something new that was not the case before GPU Audio.
Yeah, I'm constantly looking for kind of simplified. It's a bit like this, and I think we had a meeting a few months back, and I tried to use the analogy of like with the new M1 Max, which perhaps we'll get onto a little bit later. There's a Rosetta 2 layer, which effectively takes existing programs and kind of allows them to talk in the instruction sets that the new silicon understands. And so is it something akin to that, in a way that, you know, I have existing DSP plug, a VST plugin that I've written. I can't talk to the GPU because it just doesn't understand my language. And what you're doing is allow it to communicate directly with that hardware and get that benefit. Is that kind of...
I wish it could be. As an engineer, I wish it could be, but you know, it's not just the it's not just that solving the problem of translating one code to another. This is also translating one architecture to another architecture. It's like, well, I'm just trying to figure out what the good example could be. So, okay, the plane is also the plane also has some, wheels and stuff, but it also has wings and engines, and the cars, they usually don't. So they both kind of transports. They both serve the same kind of purpose, right? But they work differently. They have different nature and so on. When it comes to running some software, whether the software is Pro Audio Soft or something else, what Rosetta does is they transform x86 code to ARM based, and they reduce amount of the awesome code to execute, and there are some stuff that allows you to organize this trick. When you trying to move things from CPU world to GPU, you also need to parallelize things, like to parallelize algorithm in order to be able to run on multiple cores. And this requires absolutely different thing. You have to actually bring your own designs or invent designs in order to be able to run on GPU. The good thing is that GPU Audio offers you this kind of designs. We want to offer developers our own GPU DSP library, all of the methods that are already implemented on GPU, so you can just use it just the same way you did for your plugins. If you want to call fast Fourier transform, this will look the same way as it is for CPU code or GPU code. It's in fact just C++ code. But there is a little bit difference, and we tried really hard to hide all of the difference between the architectures. So when porting things from CPU to GPU, it should be more or less look the same.
Right. So it's like a library of kind of commands that you would call if you were coding something else. You would say, well, I need a file save dialog, and I'm not going to write one from scratch. I can just pull that in as a library. And you've kind of provided the same instruction. So, okay, right. Let's rewind a bit. I mean, as I understand it, GPU harnessing the power of the GPU for this kind of real-time parallelization of audio. It's not something that's been. It has been attempted before. I mean, what made you think you could do it, and maybe that kind of will lead to a little bit about why the company exists and where it came from.
Well, that's a very common question when people usually ask like why we did this. First of all, we didn't know that it's impossible to do. That's one of the key factor of success. You don't know that something is impossible, or someone says that it's impossible. There are certainly some fundamental problems need to be solved in order to bring the technology. And the thing is that first of all, that is Bazel. It's right here in the another demo screen, like demo /GPU Audio. This guy came to me like 10 years ago or something, just very first try. He says like, why we can't run things on GPU? Like we can run some generic computing using CUDA, etc. Why we can't do this for GPU? We never think that it will require, solve some fundamental problems of latency, fundamental problems of parallelism of DSP algorithms, and the other engineering problems. There's a ton engineering problems. You can't just run things in the way even NVIDIA explains you in CUDA SDK. You run CUDA SDK examples and it doesn't work in the way NVIDIA claimed. And this is pretty normal. Like developers know what I'm talking about. And the problem is that people tried GPUs for very regular approach to run Pro Audio algorithms. For example, there's FIR filter, and in the design with partition convolution, it could be quite easily done. You can quite easily parallelize algorithm and run it on GPU. So it basically runs there. You can run multiple instances. And if you know how to deal with latency, you get it. Like you have FIR filter implemented on the GPU. That's cool. But the problem is the Pro Audio software, and especially the new software, new kinds of software like machine learning stuff like Backbone of Steinberg, they have different things running like machine learning or even classic DSP algorithms. They require you to migrate IR filter design, which inherits data dependencies in the loop, so you can't parallelize it like out of the box. You have to think over yet another design. So it took years and it took lots of resources and investments, and people who actually have like PhD in computer science won ACM Best Paper Awards in GPU computing, etc., to figure out how to actually re-implement the classic DSP cookbook algorithms here for pro audio use, as well as running any other stuff that you need to usually to program any kind of pro audio product, including like things for compressor when you want to detect levels that break, that your samples breaks, and you want to apply attack or release mode, etc. It also should be run in parallel, so you have to figure out how to do this.
Right.
So it took like 2 or 3 years bringing all of those methods as a library, and then we use them as a building blocks for ourselves to bring our own products as just first demonstration. So now it's possible, guys, and you can actually leverage the power of GPU with the help of GPU Audio SDK, and you can build things beyond just traditional plugins. So you can run those things at scale using the GPU we unlock for you inside your laptop or desktop.
Yeah. Wow. I mean, it sounds very technical. I mean, Jonathan, you were the guy that Chris spoke to at NAMM. I mean, at NAMM, you were showing the initial kind of NVIDIA, because, I mean, it's not all GPUs are the same as well, which makes it even more complicated. So
absolutely,
back then, NVIDIA was Go. We're still in public beta at the moment, right? So what's been happening since then?
Yeah, so, and you know, just to sort of like also provide a little extra context for what Sasha's talking about, you know, on the technical side, it's really that, you know, again, everything that he mentioned, I would normally wrap up to people by saying, this is why we're standardizing it, right? Because there were so many problems that, like, you know, the best that anybody could do in the past was to create a singular one-off project, you know, that was really heavy in terms of, like, you know, trying to implement it, or super limited in terms of, you know, the use case and like the scalability. So what really gets me the most excited, and this goes into what you're asking about, Nick, is all of the really cool features that were created along the way, right? So it's like, you know, and that's what really impressed me about, you know, the GPU Audio team when I met them a couple of years ago and, you know, got started working with them, was it wasn't that they got this tech working, right? Because that's one thing, is to get a concept working and get a proof of concept happening. It's another to be able to also look at it and say, okay, well, you know, how else can we leverage this technology to bring actual next generation features, right? It's not just a matter of like wanting to use some tech. It's about looking at how that technology connects to the future of where an industry can go, right? You know, the way that pro audio can integrate and can interconnect with other industries in the future, you know, the future of where media, you know, content and production is happening. So all of that to say that, you know, that's what the stuff that really gets me excited. And since NAMM, we've actually rolled out some new features. So like we're in this period where we call early access. And I usually like to kind of describe it as, you know, like a delightfully buggy, you know, community driven process of, you know, rolling out a product, getting feedback, you know, iterating on that product, but also trying to make it so that it's a product that's usable in a professional capacity at the same time. I think we've done a pretty good job, you know, splitting that difference. You know, we started to roll out new features. In addition to the NVIDIA stuff, we went back and redesigned the FIR Convolution Reverb early access plugin. So now that it supports, you know, some very limited AMD GPUs, that was a direct collaboration with AMD. You know, it was a huge process. There's going to be some technical papers that come out of that. There's going to be a press release coming from AMD soon that people can read. And then also the next step is getting Apple support, right? So we formed a technical sort of collaborative partnership with them, and you know, we've got you know, the M1 M2 support happening on their silicon way faster than we actually thought it was going to happen. So it's like we've already been testing it internally, and the results have just been spectacularly good, on par with the NVIDIA stuff, which is, you know, basically exactly what we wanted to see happen. So, and the cool thing about early access is that we're going to continue to release hot fixes, you know, where, you know, every few weeks we'll drop a hot fix. We'll bring more AMD support, then we'll bring more Mac support. And then, you know, eventually, I think it's going to be like probably August, September, we're going to release the first ever beta bundle. So beta is a little bit different. Beta is more stable. Beta is rolling out new plugins. So there's going to be 5 beta bundles in total, running different types of algorithms and different types of processing. So the first bundle is going to be the modulation suite. And that's going to be 3 different plugins that are, demonstrating different types of modulation on GPU. So, that's kind of what's been happening. There's a lot of really cool biz dev stuff too that's been going down, but I don't want to go down that rabbit hole and bore everybody. But one of them is a spatial audio project that we're doing with a really amazing company called Mach 1, that everybody should be aware of, that company in particular. And what we're building with them is absolutely spectacular.
Brilliant. Well, I mean, I think the thing is I suppose, again, what people got really excited about in the comments of the video that we did for NAMM is they were sort of like, wow, I can just use this on any old GPU. I mean, there is a sort of an entry point, isn't there? You can't just go back and find a really old NVIDIA that was sitting in a server somewhere and fire it up. It needs to have a basic kind of, there's an entry point.
Totally.
Right?
Yeah, there's an entry point, and I could like Sasha give you kind of the technical details behind it, but generally speaking, the reason that there's a limitation on that, in terms of generations of GPUs, is because of the way that the GPU industry itself progressed. There was sort of like a sweet spot where everything locked in. The amount of CUDA cores that were available on NVIDIA GPUs suddenly started to skyrocket. Other architectural considerations made it even more possible for this technology to really scale. So in order to get, optimal or performance benefits that are actually great, there is like a bottom line for that, so.
Right.
Yeah, Sasha, go ahead.
Yeah, so I would like to share some details on this with our audience. So first of all, it's not that way expensive as it was during the pandemic lockdown. Right now, GPUs are costed with less price, less expensive even than the MSRP, which is really good. So you can expect you can get 30, 60, about $400 or even less. I'm not sure. We just need to check out at your local store, or at least I'm personally using as a benchmark Amazon costs. And certainly what you can do, you can purchase a $900 laptop that has a RTX 3060. So you are not just purchasing the laptop graphics card, you are purchasing really cool entire computing system with a 144 hertz display with all of the stuff. This thing can beat pretty much any other hardware setup that was before the GPU audio era, when you usually invest a lot of money changing your motherboard, your RAM, your CPU on some new, I don't know, I'm the AMD Threadripper or something, and you invest thousands of dollars. So we want to unlock this for users, and we support NVIDIA graphics cards starting with 900 series until the latest. And AMD is a little bit different, and the entire bunch of AMD technologies was hard to bring, and thanks for this direct collaboration with the AMD and NVIDIA engineers as well. Mm-hmm. We brought the AMD support because we use NVIDIA CUDA and NVIDIA CUDA HIP translation layer to compile the CUDA code, which is NVIDIA C++ code for AMD GPUs.
Right.
So we support latest GCN era RDNA cards, which is starting 500 or something and until the latest one. But it's experimental support. We just started things. We didn't know that we can do this so early.
Is there a limitation? Is there a minimum amount of GPU RAM that you need, or is RAM not so important on this for this processing?
It fully depends on what kind of the algorithm you want to run. So for example, if you run convolution reverb, certainly it consumes some memory. And if you want to run a few hundred channels, regular 4 gigabyte, 6 gigabyte GPU will be enough. And this is even low end GPUs has VRAM, modern low end has this amount of VRAM. And if you want to run things like Flanger or Koros, you usually don't need this. So any regular modern GPU, 2 years old, 3 years old, will be pretty okay to run things that you you can only dream on, because you just run them on the GPU that you never have unlocked.
Yeah. I suppose at this point we should probably. I think we've got a couple of videos of the early modulation things that we can drop in here. Maybe what we should do now, I mean, because we've got Basil here who has what looks like Reaper with her. I mean, how is it? What's the process for instantiating a GPU audio plugin? Is it kind of the same thing? Maybe Basil can show us a little bit about how that works in real life.
Yeah, well, Basil just show you settings. First of all, we set up things for ASIO card. It's 1 millisecond latency. We use like the rule that we run in low latency if it is 96 kilohertz, 1 millisecond, which is 96 samples. So Basil just obviously show you this. The instantiation is pretty regular one. So we used to connect GPU audio with VST3 interface currently. Yeah. So we have a Reaper DAW, and I'm gonna ask Basil to add one more Flanger instance to this track and just to demonstrate the difference. Basil, may I kindly ask you to zoom out a little bit? Thank you. Play with knobs.
So, I mean, this is pretty familiar territory. I mean, there's no kind of weird sort of thing that you have to do. That's kind of what I was trying to get at.
Yeah, you don't have to run it in console and then like route your audio through an obscure, clandestine, underground, IO interface or something. There's typical plugins, yeah.
So these are ones that you're working on yourself. So this is with the Flanger, obviously. So this is design. And so would this work just as effectively on a real-time input? Because one of the things, obviously, in DAWs, we have delay compensation, between the audio interface and the internal DSP and the USB drivers. Does the same sort of thing apply to when you're using GPU? Right.
Should work, because the minimum latency, like round-trip latency for the entire technology stack, I mean, including like sending the data from the plugin or from the tool, from any software that involves GPU audio to the GPU, making some computing and return it back, is 150 microseconds.
Wow.
So you can run one instance of anything as fast as that, and you can scale it.
That's astonishing. I mean, this is the thing that's quite exciting about this, isn't it, as well? It's just the sort of latencies that we're talking about are just sort of beyond what we would expect, even in kind of dedicated live DSP systems. We've got
Yeah, absolutely. I mean, we've had a lot of users in the Discord actually, test this out live recording and things like that. There's some guys, one of our moderators named Dom, he actually did some videos, testing it out in real time with, playing his guitar, and it sounded great. There was no latency, and he was running like I think the reverb tail must have been I feel like it was like 20 seconds or plot, larger. It was like a very long reverb tail in the convolution. So yeah, I mean, that really is the design case. And actually it's been interesting. We get a lot of questions about, okay, if this really could work, in real time for live recording, what kind of implications does this have for like front of house applications? What other implications does it have for integrating with consoles or with interfaces and, unique boxes and things like that? So that's something that like a ton of users are asking about. I mean, it's probably the number 3 question that I get is, can this be integrated into some hardware because of the low latency?
Oh, yeah.
And then one of the cool things that Sasha and the team have designed also is the ability for it to scale. So when we talk about scaling, we don't just mean like, okay, it'll work on this GPU, but it'll also work on a GPU with more memory. What we mean is that you can actually network these things together very easily over, like your home network, and you can expand the amount of DSP power you have just based on the hardware that you have plugged into the system. So, that's got huge implications, and obviously that moves to cloud ideas as well.
I would add a little bit more details to this. So as long as this GPU audio technology for developers, it does all of the magic, you can run it on pretty much any GPU, which means that you can run it on embedded GPUs, because NVIDIA has embedded GPUs you can embed in any kind of custom hardware you're building, like Teslas have GPUs. And you can run the same CUDA code like on Tesla Linux or whatever it is, or you can run it in tiny footprint device that has like 20 watt TDP or so. You can power this up with a battery. So for developers, for the other companies, indie developers, for anyone, if you want guys to have a big power in a little pocket, you can do this. If you want to make a custom DSP or synthesizer or block or anything, you can do this just by compiling the same code for your custom GPU, and this will just simply work.
Well, this was one of the things I was going to ask. Obviously, these are affecting the plugins we've seen so far are made by you guys and effects. Is it viable that we could see sort of some quite spectacular synthesis and virtual instrument plugins running?
Oh yeah, absolutely.
We have one already under development. It's called Major.
Right. Okay.
It's a pretty sick synthesizer. Yeah. And I was actually just talking to a friend of mine who runs a synthesizer, like a pretty famous synthesizer shop out here in the Southern California. We were talking about custom synthesizers yesterday, you know what I mean? Because I think, when it comes to other people wanting to build things, people are asking a lot of questions about those types of things as well, for sure. And, I know that there's actually companies too that have tried to embed, DSP. There's a particular company, I can't think of the name, but hardware synthesizers too, that can link up to this stuff is a really huge area of potential.
Interesting.
But yeah,
so you can have a hardware synth that could network into your extra GPU.
I mean, wouldn't that be just like the coolest thing ever, Nick? I mean,
that's why we call it standard.
Yeah,
exactly.
Yeah, exactly. And yeah, that's what scalable means to me. You know what I mean? Is like it expands the possibilities of not only performance for the user, but for the types of products that can be released. I mean, we could look at, I used to have this dream about somebody creating like the world's largest VR Euro rack. You know what I mean? Like a Euro rack in VR where everybody could come and patch it. And, I thought, but where would you get the DSP to power that, once it gets beyond like a certain number of instances, And so I don't know, maybe I can convince somebody to build that for me or something.
Well, okay. So, I mean, currently the things that you're making here are your own, proof of concept, aren't they, essentially? So what has to happen next for other people to kind of go, you know what, it's, how big a deal is it for, say, if I've got my own plugins and I think how big a deal is it for me to port what I've done and have it just available for for the GPU audio platform? What would have to happen?
Yeah, so I can be very honest with you. So we're just starting to reveal some things for developers, and we have plans for this September, October, and November. We are going to participate in some events, including ADC and NVIDIA GTC. During those events, we are going to basically provide like workshops and lectures on how to build things with GPU audio and how to design things from scratch. If you want to design something new that is not normally exist in the universe yet, and if you want to migrate the plugin that already exists, I assume that you build this with Juicy or you build this with any kind of your own framework or with your own methods. This is more or less pretty straightforward. So when it comes to just porting the heart of your product, which is the DSP code, it's straightforward. You don't manage threads. You don't manage the way you invoke your cores on the GPU. So you don't do the parallelization science stuff. You don't do this. You just call fast Fourier transform, you call filters, you design filters in Cascade, that's it. So this is like pretty regular C++ coding thing. the rest of the stuff, like if you want to build some, I would say, file, which is usually Cubin file, NVIDIA Cubin file or binary file for AMD, you are going to load this through the specific VST3 bridge or anything else you want to connect with. If you don't want to connect just with the DAW, but like run it as a standalone application, you can write any other app using Windows SDK, Mac OS X SDK, like pretty straightforward as the other developers do. So there's no magic there. One tiny magic is happening. It is GUI development, and we a little bit revolutionary there. By the way, we just had a talk with the SoundStack guys, and they are doing something similar to what we done with the GUI, because we found ourselves very painful to implement pretty any GUI cross-compatible for all of the operating systems. So we used to run the GUI as a web code. So it can run pretty much at any point. You can run it in your browser. You can run it inside the VST3 plugin. You can run it standalone. This will be the same JavaScript code. Or you can run this in the sandbox on your website. It doesn't matter. So we also provide some JavaScript primitives to build your knobs, stylized knobs, whether those pre-rendered knobs or you're going to use like CSS or vector animation. It doesn't matter. We just run web code because it allows us to build the same code that you almost use zero GPU force to run it. So, so to say. So, and it's also super straightforward. It's like, laying out your own website. If you program in HTML, it's nearly the same.
I suppose the difficulty is because I've spoken to plugin developers, and it's always the GUI. It's between, if you're going AU, VST, AX, whatever, it's always the GUI. Yeah. That's the pain. So just another thing, I mean, are there going to be, we've got a bridge for VST3. Are there bridges for AU, AAX, and CLAP maybe? I mean, are you bridging those as well?
So we have plans for doing so. Clearly, we will implement Audio Unit before the end of the year. In fact, we are going to roll out our own early access plugin as Audio Unit plugin that runs on M-Silicon GPU. And perhaps we can support AMD GPUs. It just depends on Metal. I'm not sure though. We didn't test that, but some guys promised that it will work. So Audio Unit, yes, before the end of the year, and the plugins will also plan to deliver them for Audio Unit and Mac OS X users. The AX, we've spoken with some high-level guys from Avid, and it just depends on partnership because AX is a little bit a closed ecosystem, so we need someone that will open the gates in order to make this thing available for AX users. The CLAP, it's absolutely the best thing that's happening with the industry right now. I'm going to say, as an engineer, as a developer, this is absolutely great standard. It, in my head, it reflects with all of the demands as a developer and as a user, with all of the features that CLAP already offer and the features that are promising. This is really cool. So one of the key things for us, why we're so interested, like GPU Audio, why GPU Audio is so interested in the CLAP, is because CLAP allows plugins to maintain thread pool. And for systems such as external DSP system, whatever it is, true DSP like Sharks, like Motorola DSP or GPUs, it's super important to maintain the CPU threads on our own side. So if Bitwig guys and CLAP guys, they can literally implement that, we will definitely join them and pour GPU Audio because for us it's essential. Currently, one more technical detail, currently our VST3 plugins limited with VST3 API limitations because there is like blocking synchronization. I'm sure developers know what it means. And the limitation is 10x, meaning that we can run 200 convolution reverb channels on GPU with VST3, but without VST3, we can run 2000.
Right.
So
there's a block. Wow. Okay, that's interesting. And I suppose the other thing is where if there was a DAW maker who went, okay, I'm just going to support this natively. I mean, is there a way to make GPU audio plugins without any of this bridge stuff? I mean, would that be the game changer for you guys, right?
Yeah, I'm gonna pay for that.
Yeah. I think it would be the game changer. Yeah, it would be the game changer for the users. You know what I'm saying? Because it's like, I mean, we're talking like, you know, we have the ability to erase the export button. You know, so your audio could just be bing, it's done. You know, it's just available at all times, non-destructive, immediately available assets. That this is possible with GPUs. But yeah, the right implementation has to happen. Yeah, for sure. But yeah, like Sasha said, we'll pay for it.
So I guess the other big question is, because all of this stuff at the moment is free to user, you know, the early access is all free, you know, and I've spoken to Sasha before about you want to make the libraries available to bring sort of democratize this. So where do you guys cash in? You know, where do people get to pay you something for the work that you're doing?
So that's a very interesting question. So we are open, guys, in all of the meetings, in all of the positive meetings. We are open for community. We are open for the industry. We are open for, you know, to collaborate with the other guys to bring the best from both worlds. I mean, GPU and DSP products. So our big aim is here to establish this standard, which is the open standard. So the others can just use it and build something on the top of it. We are going to provide the way of monetizing things once we will have some minimal viable amount of users. Today it's about 14,000 users, which is great. I'm sure not every single company does this amount of users just this short period of time.
About 3 months, really.
And it's all almost everything. This is organic traffic, so we don't, you know, pay everyone to say GPU audio is cool or something like that. So I guess this is like the demand for this technology, for solution and for features is really high. So we want to have a look at what's possible commercially, what is the best fit for the users, because we can't grow fast without community's approval. I mean, people needs to understand the value first and then to pay for it. So, you know, if you asked me this question like half a year ago, I would answer you straightforward. It's like $15 a month or something. Now we are reconsidering this price, and we want to, first of all, to provide the democratized way to pay for GPU unlocked experience for everyone. So we are something in the middle, reconsidering the pricing policy and reconsidering the way we're going to monetize.
Right. I mean, that's it. There does seem to be a real interest in this. And I think, you know, this is one of the things that I was saying to you, because you use the word GPU in your, you know, your search terms, and you use audio as well. I mean, just on a pure basis, those two are you know, the audio part's actually quite a niche, but the GPU part is massive. Everybody uses GPUs, but I mean, I can see the stuff that you were talking about, cloud. I think we spoke in another meeting about the idea of the engine being able to drive the 3D audio required for not metaverse, but you know, virtual environments, gaming, all of that stuff that can really have a paradigm shift in reality, right?
Oh, yeah, absolutely, man. And you know, it's just like both of you are saying. I mean, it's like, okay, so the organic interest is really huge. We just want to serve the community the way that they deserve to be served, right? Because it's like, you know, we want to make sure that we're not building a walled garden. But at the same time, you know, we do need to move forward, you know, with, you know, the business model. One thing that I can say is that, you know, on the partnership side, this is also why we're being flexible with the way that we work with partners, right? So like, you know, when the SDK, you know, like Sasha was saying, we're going to reveal it at one of these conferences, you know, in stages. And then once it's fully available to people, there's models for using it for, you know, no cost. And then there's models for businesses that are already driving a lot of revenue that are going to use it, you know, not dissimilar to like the way you would use like Unity 3D or Unreal Engine or like a video game engine, right?
Yeah.
But then at the same time, you know, there's the possibility of bespoke projects, right? Because, you know, we're talking about hardware implementation. There's a lot of B2B cool stuff that can actually offer not only to advance the technology, but to also give us, sort of a foundation for keeping the prices reasonable for the average user. If we're also building like these really cool non-recurring engineering, like projects, with people. So we got some really, I can't like mention who's interested, but there's some really cool projects that I think would be, it's fairly easy for like, certain companies to basically say, hey, we have a budget for this particular activation. Let's allot an extra amount of money to, build this on the foundation of a GPU server, for this production. So yeah, there's a lot of options and opportunities, I would say, from our side, but also from the side of people who want to collaborate and build products,
It's interesting, isn't it? Because we see the way that GPUs are taxed, and because making however million polygons a frame, for doing these kind of virtual environments, you turn that into audio processing. It's absolutely ridiculous amounts of power that we wouldn't even have dreamt of years ago. I imagine once this happens and people start designing instruments that can harness this power, we will hopefully see this sort of an explosion of kind of like a leap forward, like you do sometimes when you have virtualization and the way that some synthesizers are modeled. There's a sort of leap in terms of human understanding of it, and then all of them subsequent to that get better. It feels like we're entering a phase where we're hitting that plateau, and then there'll be a springboard with this sort of technology to allow much more interesting things to happen.
Oh yeah,
absolutely.
You're so right about that. I attended the GTC event, back in spring for NVIDIA. We spoke at that, but also I attended a bunch of other talks, about Omniverse and about all of these other really cool, projects that NVIDIA is building, internally. And one of the quotes that came out of that from somebody who's like super high level, VP of something at NVIDIA, he said creativity is only limited by processing power, And it was an interesting comment because, this is coming from the perspective of people that are working in the visual design industry and working with 3D, right? And they're
on the edge already. They kind of need, yeah.
Oh, they've got like a dagger in the kidney of the edge. They're so bleeding edge that they're just killing all the standard, like building new stuff, breaking things constantly. It's amazing, right? It's like they're constantly breaking through barriers. But what we see in the audio industry is not necessarily that, right? That's like the big criticism of the industry, writ large, is how, there becomes a standard, things get comfortable, all of the big sort of like, monopolized, corporations, find a way to, build something that they can like really push and like squeeze their users and stuff. I'm not criticizing anybody in particular. I'm just saying this is what users complain about, when we talk in the forums and stuff. And, being able to push the limits for the users, it's like if we provide, so the thing that came out of the GTC was every time NVIDIA provides a new boost in performance, the creators immediately max it out, right? And they immediately max it out. They create something new. And then occasionally, every few years, there's like a particular breakthrough that sort of provides like an exponential increase, right? And I feel like in the audio industry, I haven't really seen that happen yet, right? So, that's what we want to try to instigate, with GPU audio is like a creative push or like a creative evolution because of the allowance or the access to this power that people are going to be able to have. So to me, that's kind of like the vision that really drives my thinking, when I'm talking to you or like talking to other people. So whatever you said really resonated with that, and you kind of got me going on that. But yeah, you're totally right about that. We need that more. More power. It's, I'm a 90s kid. I'm thinking of Tim Allen, the more power.
Yeah. But then at the same time, we've got there are lots and lots of hobbyists or people who are struggling to kind of be able to afford the power of new computers, but they've already got the power sitting there and they can access it because, Sasha, you were talking about the round trip. Are there limits to the number of instances of things that can be run on sort of base level GPUs, or does it just get really crazy really fast?
No, there are no physical limits unless everything you have implemented in your hardware, like RAM, like amount of cores, etc. So it just depends on what the model of the GPU you have. Basically, I also wanted to add to the previous conversation regarding like the future of pro audio powered with GPU is that right now, there are trends, right? Like spatial audio and machine learning. So When it comes to spatial audio, when it comes to processing things, we usually work with tens or even hundreds of channels, right? Each channel is independent, which means technically from engineering point of view, you can run this in parallel and independently you can compute this. So this is the perfect fit for running things on GPU. And if you want to make some very high complex things in your spherical spatial audio stuff, like tens of thousands of reflections, some very complex rooms, etc., etc., etc. This should be done on the GPU. The same goes for machine learning. Right now, what happens with machine learning in the Pro-Audio is that you just pre-train the model and then you run the processing part, which almost does nothing. It's like it does not require too much of power, but with a lot of power, you can actually do things like continuous training.
Right.
And the training, this is something that requires a lot of computing power. What if we can do adapted things for broadcast or for live performances, including like adaptive noise cancellers?
I know. I could imagine stuff like feedback suppression, continuous tuning of a live PA system that is just across, however many bands you fancy. Really complicated algorithmic quadraphonic multi-channel reverb. All of that stuff is right there, right?
Yeah.
And you can power this up with the GPU of your laptop.
That's what I was just going to say. All of that, and you don't have to go out and spend $4,500 on a fancy interface with like aluminum casing, and it's just like, you could. If somebody built something like that, I'd be all for it, right? That's awesome, but the ability to have that kind of stuff accessible on your average computer, is really exciting. But think about it too, Nick. Like a few years ago, this wouldn't have been the case, right? Like the timing would not have been perfect because gaming laptops were the GPUs that were getting. I remember when like a high end, like the 1070 or 2070Q, like the really high powered RTX cards and stuff started making it into laptops just a few years ago. So and then now with M1 and M2, it's like the timing couldn't be better in my opinion. For this to unify the user's access to it. Sorry, Nick, go ahead.
Yeah, no, I think that sounds like, that's the other thing, at the moment, yes, this is PC only, but the Macs are coming, and then when you can hit all of those platforms, then you're kind of, you're golden. I had an idea for an instrument that used reverbs as oscillators. So you could freeze things and use that as the basic for an oscillator. So if you could build that one for me, then I'd be very pleased to test it.
Let's hop on a call.
Let's collaborate.
I'll write up an MOU for you, and we can get started next week. Yeah,
fantastic.
That sounds amazing. I'm actually a huge fan of feedback based oscillators and stuff. I'm nerding out on that with my little Eurorack system all the time. So yeah.
Well, guys, I don't know what's next. It sounds like you're kind of shooting for the stars, and the things are moving apace. And I think once you gain this, as this momentum builds and builds and builds, things will presumably start to happen really quickly. If you've got a kind of, you said you're aiming for the autumn, winter to kind of start to roll out early access to M1 and M2 chips. What's next there? I guess you can't reveal all the family secrets, I realise, but goals.
Well, the DAW, but I'm not going to call it the DAW. I just say that for people to better understand what it is. But imagine there are like collaborative tools, right? All of the collaborative tools that exist, they just re-upload things, synchronize things in the cloud, and reuse the assets. Yeah. There is no real DSP power located in the cloud that you can use real time to render things real time to provide continuously the result for all of the collaborators in the audio project. For example, in post-production, like this is not happening today yet. What if we can bring the DSP power in the cloud? And this thing can change the workflow de facto, because right now, every single time you need like upload things, grant access, talks with someone over the messenger or something, or you need like render things locally and then again to upload them, or you need to upload stamps, etc. We're going to eliminate that. We also are going to eliminate things like exporting, rendering in some formats, etc. We're going to eliminate that as well. And this can be and should be done with the power of GPU that are scaled in the cloud. Because all of the servers, they have those data center grade GPUs available. And we're going to, provide the new workflows that can allow enterprise grade users produce more content and faster.
Wow. Okay. Interesting. Wow, guys. I mean, I think the sky's the limit. And it'd be great to talk to you again, in maybe towards the end of the year when we can see where things are going. But so what if people want to kind of go, yeah, I want me a piece of this. What do they do? Where do they kind of go and find out about what you're doing and get on the program?
Yeah, so it's super simple. So right now we're running early access, like we mentioned before. In a month or two, we're going to roll out beta, and beta is going to run in parallel with early access. Early access will be a continuous program that will always be releasing experimental features, new GPUs supported, new, plugin format supported, while the beta is going to be more of like the stable, monetized releases and stuff at some point, or, maybe some of them won't even be monetized, but some of them will, right? So the way to get involved is just go to either gpu.audio, or if you want to actually download something right away, go to earlyaccess.gpu.audio. And all they have to do is, create an account, log in with your Google, or just create a unique account. Immediately, go to your portal. You can download the plugin. The various versions of the plugin are there. Always download the most recent hotfix is my suggestion, so that things aren't breaking. And then, just run the installer. Very simple. Test it out. Dive into our Discord. There's a button on the website for the Discord server. We've actually also been hosting live AMAs and streams every week on Fridays, where we're featuring sort of like a back and forth. We're doing developer community people, interesting developers and third parties and stuff. And then we're doing producers. So, this week we have an interview with Nick Mack, who is a really cool, producer, 24 Karat Golden, Post Malone, things like that. He's super tech heavy and really into he's a futurist, a technologist, futurist kind of guy. And then the following week or sometime in August, I think we'll have, Joshua Hodge, from the Audio Programmer. So, we're kind of doing that. So that's how people can get involved. They can interact with the community, share their thoughts. And then, once the first beta suite or beta bundle rolls out, the other ones are going to be soon to follow. So we have a very busy roadmap to the end of the year. There's going to be a lot of stuff coming out. And then, we're hoping to, just build this community out as much as possible so that we can really show the world like what it is that is possible with these plugins and, hopefully build that reverb plugin that you're talking about too.
Yeah.
Let's just say that's in there. Let's say that's a Q4 project or something. And,
okay. Next year, perhaps. Yeah. Well, thank you. I appreciate that. John and Sasha, and also Basil, thank you very much indeed. I haven't heard a lot from you, Basil, but appreciated you showing us that. I'm sure you guys have got a busy day and a busy schedule ahead of you, but thank you very much for talking to us.
Thank you. See you next time, Nick. Thank you.
Yeah, Nick. Thanks. It was a bucket list to get to talk to you. Thanks.